Education Society, redefining excellence.
Hello students, in today's video lecture of Basic Electrical Engineering, we are going to learn the AC fundamentals. The first point is generation of alternating current EMF. Now this alternating EMF can be generated by two ways. First one, by keeping magnetic field stationary and rotating coil. And second, by keeping coil stationary and magnetic field rotating. All over the world, the second type of construction or operation is preferred. However, for simplicity, we have considered the first one, that is magnetic field is stationary and the coil is rotating. Now in this figure 1, the magnetic field is stationary produced by the North Pole and South Pole, and in this magnetic field the coil is rotating in say CCW direction, counterclockwise direction. By using the prime mover. Now see, the coil has, every turn is made up of two conductors and many turns form the coil. Every coil has two coil sides. Say coil side CD has many number of turns, coil sides AB has many number of turns. Now at the present situation, when the plane of coil is perpendicular to the direction of magnetic field, then the coil side, this coil side and this coil side, both moves parallel to the lines of flux or magnetic field, and no EMF is induced in it. So this is the case when the zero EMF is induced in it. So the same diagram can be shown by other ways. That is in a 2D, looking from the front side and say rotating in a clockwise direction, keeping North Pole at the top and South Pole at the bottom, and looking from this side. So the diagram will become like this. Say this is North Pole, this is South Pole, and this is the magnetic field produced by North Pole and South Pole. The direction of magnetic field is always from North Pole to South Pole as shown in the figure. Now say this is the reference axis, that is zero EMF axis, which is shown here. Say this is x and this is minus x. So this is y dash. Now this coil side, looking from the front side, AD we can look. Say it is rotating in counterclockwise direction. With velocity, linear velocity phi. Say it is perpendicular to this one, and say the angle made with the reference is theta. This angle is theta. And therefore, this angle is also theta. Now, when the coil is rotating, it cuts the magnetic flux. And according to Faraday's laws of electromagnetic induction, EMF get induced in each coil side. Now here this velocity is resolved into two components. One is horizontal component, that is perpendicular to the lines of flux, and other is parallel to the lines of flux. So the component of the velocity phi sine theta is responsible for flux cutting. Is responsible for flux cutting. So at the reference, when theta equal to 0, EMF induced in the coil is 0, because two coil sides, that is A and D, these coil sides moves parallel to the lines of flux, and therefore no cutting of the flux, no EMF is induced. But when the coil starts rotating in a counterclockwise direction, it cuts the magnetic flux, and according to Faraday's laws of electromagnetic induction, EMF get induced in it. The magnitude of this induced EMF we have already obtained by dynamically induced EMF, that is BHV sin theta in one conductor. Now let us have a derivation of this one. So let capital B flux density in Tesla. L is the active length of the coil, side or coil in meter. B, breadth of the coil. Say this is the breadth of the coil. B is the breadth of the coil in meter. Then area equal to L into P in meter square. N is the number of turns in the coil, and this is equal to number of conductors in each coil side. Number of conductors in each coil side. Remember, two coil sides makes the one coil. Say AB is one coil side, CD is another coil side. The two coil sides makes one coil. F, frequency of rotation of the coil, in revolution per second, RPS. And phi is the linear velocity of the coil in meter per second. So when coil moves in, say, counterclockwise direction, the coil sides cut the magnetic flux and then according to Faraday's laws of EMI, EMF get induced in it. Therefore, EMF induced in one coil side having n conductors equal to NBL phi sin theta. Because this phi sin theta is the where theta equal to omega t, where omega is the angular velocity. Therefore, EMF induced in two coil sides equal to twice NBL phi sin theta. But velocity phi equal to pi b, means velocity is nothing but the displacement upon time, that is during one rotation the distance covered is pi b, where b is the breadth that acts as the diameter of the coil. B is the breadth or diameter of the coil. Divided by time required to make one revolution, that is 1 upon f equal to pi bf. Putting this value of velocity here equal to 2 times nb L pi bf. Now here L and B, product of and L and B is nothing but area, and therefore here it is sin theta equal to 2 pi f, then L into B is A, so BAN sin theta. So when theta equal to 90 degree equal to, so this can be written as equal to E max sin theta. So when theta equal to 90 degree equal to E max, and therefore E max equal to 2 pi f is nothing but omega band volt, where omega equal to 2 pi f, angular velocity in radian per second. Angular velocity in radian per second. So this equation for the sine wave, this equation is of sine wave, standard sine wave E max sin theta, where theta equal to omega t. Because the angular velocity is displacement upon time. Say the distance in terms of angle is theta and time required is t, and therefore theta equal to omega t. So this is the expression for sine wave, and therefore EMF induced in the alternator or a generator follow the sine rule that can be shown on the next page. Now this is the EMF induced in this coil, and if say the load is connected, say this is the lamp or a load, it's connected across the two terminals of the coil, current will start flowing.